All right, we're back. So next we're going to draw. We're going to put a person right here. That person is going to have a well. I always get mocked and ridiculed for how I draw a well. So I don't know the best way to draw a well. You can pick whatever you like. I make mine look somewhat like a sprinkler head. So there's like a handle right here, and then there's a spigot, and the water comes out there. See that? It's the best I could do. You can make your well have a bucket, and like the bucket comes out, whatever you want. But that well is going to have to draw water from the unconfined aquifer, so that this person can consume the water. So we have consumption. You as an individual, you release water through natural processes in your body. What are some natural things that release water out of your body? Good. So you got urine. Tears does, but sweat, good. So we got urine, perspiration, and then very good, respiration. So we're going to list perspiration first. Then we're going to list respiration. And those are just going to go out to the atmosphere, because when you respire and breathe out and water vapor is present in your breath, it just stays in the gaseous form. When you sweat and it evaporates off your skin, that goes into the atmosphere as well. But when you release water in your urine, that's going to go into a water body eventually. And we're going to call that sewage. You can draw water from unconfined aquifers, but you can also draw waters from confined aquifers. We're going to drill another well. Again, feel free to draw your own well that's possibly better than mine. But there's another well that's drawing from the confined aquifer. And we're going to draw a factory right here. It's going to look eerily similar to a house. Sorry. Just trying to keep the spacing going. It's a factory. Industry. So this is supposed to represent industry. So you could have water going to industry, and then that water will come out as waste. So the reason why we're putting industry there is because we want to show that industry produces waste that could possibly contaminate drinking water, the groundwater, and that water could move its way into the body of water over here through groundwater flow. Just to show you the possibility of going from unconfined or confined. The reason why I chose the industries to go to the confined is usually industries will try to draw water as much as they can. And confined aquifers tend to have more water because they're harder to get to. In addition to drawing water for the industry, we're going to put some crops over here. So just I'm going to draw some like grass, like wheat. Right there. And we're going to take water from the well right here, and we're going to put it onto these crops. What's the name of that process of watering crops mechanically? Good. So this is irrigation. Now, farmers, unfortunately, sometimes apply too much water to crops. And if they apply too much water, what happens to the excess water that cannot be absorbed by the soil? It could flood and then run off eventually. So we're going to draw an arrow right here to show that there could be runoff. So you take all this into account. If you take that waste coming from the industry, if you take the runoff coming from farm fields and the sewage coming from humans, the end result is polluted H2O on this side of your picture. We're going to label this picture from all the way on the left-hand side to where the human is as the natural, sustainable system. And we're going to start from the middle box, the human. We're going to overlap a little bit. We're going to overlap the human and go all the way to the right-hand side. We're going to call this section the human alterations. And these human alterations decrease the sustainability of the system. We overlap the humans because obviously humans can decrease sustainability with how we access water and how much we consume it and what we consume it for. If we were to just use it in a fashion that was sustainable, it's natural. If we use it too much, then obviously that's a human alteration. I don't have the next page on my slide, but you do. So what I'm going to do, you guys turn your page, go to the second page. I'm going to continue to write on this, okay? The second page is asking you to apply the laws of nature to the cycle and understand how they get impacted by the laws of nature. So the first law that we're going to talk about is the law of gravity. Can somebody look at the diagram and tell me a location, a process on the diagram, or a location on the diagram that's impacted by the law of gravity? Good, so you got precipitation. Where else? There's a couple more that would be important to know. The runoff, good. And the last one, gravity is going to always pull things downward. Where else is the pull downward causing a process to occur? No. Waste doesn't go down. Look up something else, though. No. No. Percolation. So let's label precipitation. Put a number 1 by precipitation, a number 2 by runoff, and a number 3 by percolation. We're numbering them because on the page 2, it asks you for the number of the section that applies. So for the law of gravity, we can say steps 1, 2, and 3 all show the law of gravity and its impact on the water cycle. And what is gravity doing to water in every single one of those processes? That's what gravity does. What does it do? It pulls water down closer to the far down as it can, whether it be the surface or whether it be into the ground. Okay. So if you want to write that in your explanation, you could talk about how it pulls H2O downward to the surface, into the ground, or into a body of water. For conservation of matter, you don't necessarily have to label a section of the diagram because it's the whole diagram is demonstrating the law of conservation of matter. The law of conservation of matter states that matter cannot be created or destroyed. Okay? So what I want you to understand is the water that we have on Earth, what happens to it? And does it ever go away? Nope. So if you want to write just a quick summary, it's basically that H2O cannot be created or destroyed. Only phase changes. The last two laws that we're going to talk about is the first and second law of energy, or thermodynamics. Again, this is some chemistry stuff. We're going to go and label energy